Did you know that this derivative has a hidden secret that you probably haven't learned in class? You're going to want to stick around because it completely changes how the answer looks. For this problem here, notice that with the product rule, this absolute value provides a problem for us. But if you remember from my other videos, I like breaking up the domain into two parts with an absolute value, where we're handling one part where x is greater than or equal to 0, and then when x is less than 0. But before I handle the absolute value here, let's first tackle the derivative of e to the cosine of x squared, because that's going to be an answer in itself that we're going to reuse for different parts of this problem. Now, this is a simple chain rule application. So its derivative is just going to be the outer function, which is e to the cosine of x squared, and then times the derivative of the inner function, which is that power, cosine of x squared, giving us this expression, e to the cosine of x squared times negative sine of x squared times 2x. And then when I rewrite this, I'm left with this following expression that we can reuse. Okay, now going back to the absolute value, I want to work with case 1. What if x is greater than or equal to 0? If I restrict the domain in that way, then we know that with the absolute value, I can simply drop the absolute value altogether, because for a non-negative number, the absolute value isn't going to do anything. So rewriting the original problem we're solving for the case where x is non-negative, now we can easily use the product rule here. And if you remember, you take the derivative of the left, which gives you the 1 here, times the right function, this e function, plus now taking the derivative of the right times the left here, which is going to be x. And for this right part, notice that that's just from what we got above for the derivative of the exponential function. Now, when you combine terms and simplify things a bit, notice that you're going to have e to the cosine of x squared in two different spots here. And so I'm going to factor that out. And now we know that for a non-negative domain for x, the derivative function is going to look like this. So stick around for a bit and hold that thought, because you're going to notice something interesting about what we get when we're now handling the case where x is negative. Now in this case, again, we don't want to work with an absolute value function, but we can actually drop the absolute value function here and instead replace it by putting this negative in front of x. Try it for yourself. You're going to see that these two expressions are equivalent. And so now when you solve this derivative function for the case where x is less than 0, we can use the product rule as well, right? And so I'm going to go ahead and do that here. I'll end up with the derivative of this left, the negative x, which gives you negative 1 here, times this e function, and then plus the derivative of the right, which this again we solved earlier in the video, and we can reuse it as is, times the left unchanged, which is negative x. And once again, we're going to have e to the cosine of x squared in two different places here. So just like before, I'm going to factor that out. And voila, I get this expression now. And you know what's really interesting about this, and this is where this hidden secret's going to come in for this video. Notice how this expression for the case when x is less than 0 looks oddly similar to the case that we did earlier when x is non-negative, right? Comparing these two expressions here, the only difference is the negativity of what's in front of the 1 term and the 2x squared term. Now, normally you would just answer the question here and you would say you're done, but sometimes there are real-world applications where instead of having an answer here that's a piecewise of two parts based on the domain of x, what if we can actually combine these into a single equation? So there is this idea of the signum piecewise function. I'm not going to use it here. You can research that. I feel like it's a bit of a cheat for this video, but instead I want to show you how to creatively create your own switching function yourself. Check this out. If I gave you the expression x divided by the absolute value of x, we can use this expression to determine if we should have a +1 multiplier or a -1 multiplier based on if x is greater than 0 or when x is less than 0. Because check this out. When x is greater than 0, you get a 1, right? Nothing changes. And then when x is less than 0, it flips. It becomes a -1. So what this means then is that for this derivative problem we were solving in this video, I can take these two expressions up here that summarize what we've done, and based on that switching function, I can use that to control the positivity and negativity of these two terms, the 1 and the 2x squared, which means I can actually combine our piecewise functions in our answer and reduce them to a single equation, where here I'm going to have my switching function to the right. Now, there is a caveat here, and there is a domain restriction that we have to be mindful of. Notice that x cannot be 0 here because we would be dividing by 0, and that's not allowed. But you tell me in the comments below as your homework how we can handle that case.